So, good evening, students. Very good evening. This is Dr. Kamalkar Sharma, your mentor, your guide, your friend. Again, come with another video. But I want to just link that video with the previous video. In the previous video, we stand over here with the applications. So we discussed in the previous video about the counters. How the different types of counters are available, what's their configuration, how they're going to behave, what are the different roles, how can we make a good counter, and what are the different states of counter. We also discuss modulus counter. We also discuss various timing diagrams. We understand what is timing diagram and how can we, understand or make a timing diagram, and what kind of timing diagram is good for which kind of application. So that we discussed in the previous video. We also discussed the application of the counters. I segregate the application for Ring and Johnson counter, right? Now we are going to start with another topic, that is your shift resistor. So when I say resistors, I don't know what comes to your mind, but students, when I was studying in engineering and I passed out in the year of 2004, then when somebody told about resistors, I was thinking about, what kind of resistor they're talking about. Okay, or whether it's my kind of resistor with a physical resistor or digital resistor, because nowadays I'm talking about, see, I entered in this engineering field in the year of 2000. It is 22 years gone, right? And believe me, at that particular point of time, we were not very much dealing with this digital electronics. I remember I got my phone, that time the Motorola phone were used, and I used that particular phone, and I bought it in the 2003. My father gave to me because I was in industrial training. So what come to your mind? Just write in a comment box. I just want to know what this new generation is thinking about resistors, or what the first thing that come into your mind. Okay. So when we talk about resistors, we are talking about data, because nowadays we are dealing in the world of 5G, right? We require data, and in a very good way. We are not surrendering ourselves to less amount of data. We require data for our social purposes. We want to be social active. We want to do certain work. We are looking for Gmails. So much data, even some Gmail, some providers, some mail provider also, stated that they are not in a position to handle this good. There's a huge amount of data, but still, the data has to be understood. Data has to be segregated, diversified. Okay. So when we talk about data, we are talking about registers, we're talking about hard drives, we're talking about memory. And in this lecture, in this video, we will talk about these different type of memories along with registers, along with data transmission, because registers play a very, very important role in data transmission. So without getting more delay, as using delay flip-flop, as we already discussed in the previous video about flip-flops. Okay, so you can check on the previous videos where we discuss about D and T flip-flop. Let's discuss that how the data can be transmitted or transferred from one point to another point. So for this, we are having shift registers. Now, what this shift registers, they are nothing but a kind of sequential circuit. I already made one video on combination sequential circuit. Okay, check it out, students. Shift registers are a kind of sequential circuits and for storage of digital data. But they are comprising of certain flip-flop, and in such a way the output of one flip-flop will become the input of next flip-flop. When I mention this, I'm talking about asynchronous operation that we already discussed in detail, that we are talking about asynchronous operation. So now two functions are been decided or have been accumulated for shift register. One, shift the data within the register or in different registers. It can be left, it can be right. Okay, from right to left or left to right, or it can be bidirectional also. Similarly, store a data. It can be in a serial, in a parallel. If you remember, I discussed in the previous video when I was discussing counters. I was taking an example of serial and parallel output or serial output, what we mean by serial transfer, what we mean by parallel transfer. So there are four modes of configuration in which, or four modes of operation in which we transfer a data or transmit a data or transfer a data. One is serial input, serial output. That means input is serial and output is serial. Very, very good mode of operation, but not that much fast as we require. Then we have serial input, parallel output. Yes, the input output operations are different. So naturally the coordination problem is there, but yes, we use in certain cases. Then we have parallel input, serial out. It is automatically the same. When we talk about parallel, understand, we're talking about a huge chunk of data. When we are talking about serial, we are talking about a train of data. Understand this, right? And the last one is parallel input, parallel output, very fast mode of operation. And normally it is being used in various applications, various devices also. You are using USB. In USB, we are using PIPO. Now you can see first mode of operation where we're talking about serial input, serial output. When I talk about serial input, serial output, you can see that I am having a data and a clock. That means I am using D flip-flop. So remember my words, students. I already discussed, already told many times in previous videos. We use D and T flip-flop instead of JK and SR. Okay. And we can convert from SR to D or D to SR or JK to SR or T to SR or D to T. That I already discussed in one of my video. You can check out beta in the video of combinational and sequential circuits. So when we talk about, we are having different stages, stage 1, stage 2, stage 3, stage 4. In the data input, we are having data flip-flop are being used, and this is serial input and serial output. The clock is same, that means we are talking about synchronized, and the different stages are there. Similarly, with parallel input, parallel serial output, if I go back, you can see in serial input, serial output, the serial input is given, similarly serial output is given. Output is taken out, data output. But when we talk about parallel input, serial output, then we are giving a parallel configuration, as you can see, and the serial output is taken in a very simple way. But that is not recommended. Similarly, this is serial input, parallel output, again not recommended, but yes, you can take it a simple one. Input data is taken out and parallel output is taken from the aligned bit. So the data is transferred also, and you're taking a bit out of this. So Q0, Q1, Q2, Q3. If it's a 4-bit, and if it is a more, you can use the number of flip-flop can be increased. This is parallel input, parallel output. I already told that clear signal would be given to every flip-flop in a synchronized way. So a single pulse can clear all the data, and you are using D flip-flop. I hope this is clear. I go a little bit fast in this shift register. Why so? Because we already discussed all this in a previous video. Okay. Now, if you want to know that how the shift register work, then you have to understand two things, students. Now, what are the two things? You have to understand which mode of operation we prefer. Okay. So you have to understand that how this. So when we talk about at serial input, serial output, two things we are talking about. Now in front of you, you can check out. I put two modes of operation which are very much in demand. That is serial input, serial output, and parallel input, parallel output. When I say like this, we are having a data input using a D flip-flop. Okay, and the data is transferred or transmitted to another flip-flop, and the clock pulse is same. So it's a synchronized operation. Similarly, if you see over there, this is also a synchronized operation, and the clear pulse is also given A single pulse can clear all the data, the past values. But what is the difference? You are giving a serial input and you are taking a output at the end of the operation. Whereas in this case, you are taking the output at every operation of the flip-flop. Right? So it is parallel input, parallel output is a fast mode of operation as compared to your serial input, serial output. And if I say, if you used LAN transfer of data, might be you write in a comment box, how many of you use the mode of operation and the transfer of data using LAN. When you transfer a data using LAN, you're talking about SISO, which is nothing but serial input, serial output. But on the other hand, if you talk about USB, if you're talking about some large amount of data to be transferred, chunk amount of data to be transferred, is parallel input, parallel out. I hope this is clear. So this amount of data, this is a modus operation only, but we have our memories also. And these memories are now a part and parcel of our life. We cannot go away or avoiding these memories. We cannot say, okay, we have memories, even though CSE students especially, see, they are using large amount of data, and I just leave to you, you can write in a comment box. In one of the placement interview, one of the interviewer asked a student, what amount of RAM and what amount of ROM you used? And in a reply to that particular question, a student told that, sir, I am using 1 GB of RAM and 2 GB of ROM, and stayed with the interview, said, okay, thank you, you can go. So, see, nobody is going to ask you a question that, yes, what is RAM, what is ROM? They are interested that whether you know about RAM and ROM or not. So today in this lecture, in this video, we are going to discuss a little bit of giving an insight about RAM and ROM, or different types of memories, which are nothing but your semiconductor memories. We will discuss about classification as well as the application of these memories. We will also understand what is the segregation, how these memories, where these memories can be used, and how their application, how their operation performance can be enhanced. That also need to be understood. So semiconductor memories, in which we are talking about volatile and non-volatile. I hope you understand the meaning of volatile, which is random, which is easily available, which is easily accessible. Various definitions you can check. So semiconductor memories are basically segregated in two ways: volatile and non-volatile. And in volatile, we are having a RAM, which can be your SRAM or DRAM. When I talk about SRAM or DRAM, I'm talking about static RAM and dynamic RAM. In your laptop, the laptop what I am using right now, it is having a DRAM. SRAM we can also have, not a problem. But I am having a laptop right now, which is having an AMD processor. And India, we normally don't use AMD processor. We are normally use Intel processor. I'm leaving you with a question that why this is. Okay, and nowadays we are using AMD also, but why it was not popular earlier? Please answer me in the comment box. Definitely, I will answer you in the comment box if the answer is not right? So volatile, yes, SRAM and DRAM, and in semiconductor memories, we are talking about non-volatile, where we are having a ROM and flash memory, where the flash memory is incorporating your NAND and NOR configurations. But in ROM, we are having a PROM, programmable ROM, EPROM, and EEROM. If I talk about memory, you have to see over here from the CSE point of view, from the electronics point of view, from the electrical point of view, from the automobile point of view, or mechanical point of view. You can see we are having a CPU, we are having a ALU. We know what is CPU is, central processing unit. We have some chipset which contains several controllers. Okay, the memory controller, you know very well the part of chipset, and I'm not going into deep into chipset, what is chipset and what is bus, but yes, I just want to say the bus is basically transferring information from one point to another point. And we are, these all are done on the motherboard. So we are having memory bus. This is basically a diagram which is showing that yes, how this different connections, Ethernet. Now, most of the students are not knowing about Ethernet and internet. They're not knowing that what is the difference between both of them, whether they're using IP4 or IP6. They're the basic things, beta. Right? Please answer me in the comment box. If you're not clear, I will make a video on this with the basics for computers and we'll discuss with you. The memory semiconductor based integrated circuit, you can check out. We have a CPU register. Then we have a cache memory, which is basically to use to reduce the mismatch between your keyboard and the computer speed, because they are not matched. One is analog, one is digital. Okay, so cache memory, level 1, level 2. Then we have a RAM memory. It can be physical memory, it can be virtual memory. Right now, nowadays we're talking about more about virtual. Whether it's cloud, whether it's grid computing, whether it's cloud computing, whether it's ubiquitous computing, whether it's fog computing, right? So I hope you are aware about fog and cluster computing and cloud computing. If you're not, just see my previous videos. I discussed about the difference between fog computing and cloud computing. We have different storage devices in which we are having a ROM BIOS, basic input output system, then removable devices. Under this we are having USB, the networks, internet storage, and hard drive, that is permanent storage device. Right? You can see that mass storage devices, you can see removable media drive, you need removable medium, central processing unit, which is having a registers and cache memory. And the registers, combination registers capacity depend upon the type of processor we are going to use. Then we are having input source in which we have a keyboard, mouse, removable media, scanner, camera, remote source, or other sources. Any desk you are using sometime. So these are also having some kind of memory. And just simple question: why your system hang? Just see somewhere every process is given certain amount of time. P1, P2, P3, P4 that you will study in operating system, but I'm just giving an overview. When this processing time overlap, then your system hangs. Okay. This is a memory structure. Again, the repetition of this. So you can check out the memory is volatile and non-volatile. You know very well. Then ROM and RAM can be seen. Then you know very well ROM. Then flash, you are having NOR and NAND, and hard disk, CD, DVD, the drives are also one kind of memories. Again, just see, this is not clear to many students. When I say 64K, how many memory allocation it is having? It is having 1K is nothing but 1024, so 64 into 1024. And the memory allocation start from 0 to that particular value. Similarly, if I'm having 1024K, I will say 1024 into 1024, these much memory allocations or memory allocations I would have. And these memory allocations would be in RAM. So you can see SRAM or DRAM. In ROM, we are having masked ROM also, in which we tag the values. We have UV EPROM also. Okay, you can use UV as an input source for removing the data. Okay, so it is able to programmable read-only memory. So that is your flash memory. Then we have volatile memory. Yes, it requires more power to store information like DRAM, DDR. SDRAM is a dynamic in nature. SRAM is basically cache memory. And you can check what is the maximum value of cache memory we use. It is nearly 10 MB. To best of my knowledge, if you know that cache memory, more cache memory value, you can write in a comment section. Okay, but what up to my knowledge, it is available till 10 MB. So we know that what is the difference with DRAM and SRAM? See, the DRAM consists of tiny capacitors that leak electricity, but in SRAM we are using flip-flop. That is very, very important. Very, very important. In SRAM we are using D flip-flops that you are incorporating in the traffic lights also. Again, DRAM require very few milliseconds, but SRAM hold it constant as long as the power is available. Now I think you got your answer. One of the students asked me the question, sir, SRAM is good or DRAM is good, right? So for your, when you're talking about control S, right, when you're doing the data is removed, here the difference between SRAM and DRAM clarify. DRAM is inexpensive, but SRAM is very, very expensive because it has to store certain amount of data for certain amount of time. It is slower than SRAM, SRAM is very fast, but it is very expensive also. It is made normally in cache. Cache memory is basically SRAM. Okay, many bits per chip, cannot store many bits per chip, uses very less power, uses very more power in SRAM, generate less state, but it generates very, very a good amount of it in SRAM. So DRAM is main memory, whereas SRAM is for cache. So cache is memory. Now our research is going on. I expect many students to do the research in this area also. This area is basically known as VHDL, and you can search out what VHDL is all about. And we have many labs in India also which are working on this area. Non-volatile, we are talking about non-volatility and the stored information. So we know that electrically addressed ROM, electrically addressed means electrically can be erased also. Programmable read-only memory, masked ROM can be there, EPROM can be there, the electrically erased program read-only memory can be there, and the flash memory. Mechanical address system we have, it can be tape hard disk, it can be optical disk, CD, DVD, you know very well. Most of the, how many, just write in the comment section, how many of you already knew that your CD and DVD are basically optical disk or magnetic disk? When we talk about magnetic disk, we talk about floppy disk, and when we talk about optical disk, it is CD and DVD. Then we are having a ROM, read-only memory, very crucial information that is required. So that crucial information essential to operate the system we use with to boot the computer. Right, it is not volatile and retain its data. Different types of it is used in calculator and peripheral devices. This is very, very important. This is normally asked in through Venn diagram also. So you can see that in EPROM and double EPROM, electrical erased PROM and EPROM, the flash is basically another kind of memory, and DRAM and ROM somehow, somewhere can be integrated, can be clubbed together. So in the case of flash memory, it is very, very good, highly reliable, low power, high speed architecture, but very difficult to make, very difficult to construct or make to increase its retentivity. In DRAM, yes, high density, low cost. SRAM is a key feature in the memory area now. Most of the researchers are working in SRAM. So in this video, we discuss about memory allocations, we discuss on memory interfacing, we discuss about counters, we discuss about different types of structure, different configuration for the counters, even though for the memory architecture, right? So what we comprise is digital electronics. What we understand from this video, I hope you understand that how the memory can be used, what are the applications of memory, how can we segregate the memory, and how can we use the counters for different applications. This is all from this video. I hope you like the video. If you like it, then you can subscribe this channel, and you can also go ahead with this channel. You can share this channel. I'm making the video as per the requirement of the students, so you can also check out other videos which are of good value to your curriculum and to your knowledge. Thank you very much.